do a practice problem with finding information about an image in a concave lens. So we use the thin lens equation just like we do for convex lenses and mirrors, but we're going to keep track of our signs. So this problem reads a concave lens with a focal length of 10 centimeters is in front of an object that is 30 centimeters away. Where is the image produced? And what is its magnification? All right, so we're given the focal length. The focal length is 10 centimeters or 0.1 meters. It's concave, so that focal length is negative. So that's the important part that we want to keep in track of with using the thin lens equation. We're provided that object distance of 30 centimeters or 0.3 meters, and we're interested in both the image distance and the magnification. So let's look at our thin lens equation. We have 1 over the object distance plus 1 over the image distance, remember, is 1 over the focal length. So I'm going to solve for the image distance. I have 1 over the image distance is equal to 1 over the focal length minus 1 over the object distance. Our focal length is 0.1 meters negative minus 1 over our object distance of 0.3, and this gives us an image distance. If I add those two together and take the inverse of negative 0.075 meters or negative 7.5 centimeters. So our image distance is 7.5 centimeters. The negative tells us what? It tells us that the image is on the same side of the lens as the object. And if we think back to image formation in concave lenses, they produce virtual images on the same side as the lens. So go back and look at those ray tracings and give you a reminder of that. And we should have gotten a negative. Thank goodness that we did. All right, so that's part A. Part B is the magnification. The magnification is the ratio of the heights of the image to the object, but it is also the ratio of the distance. So remember, it's minus the ratio of that distance, the image distance over the object distance. So we can use the image distance that we determined, negative 7.5 centimeters, our object distance of 30 centimeters, and we get a magnification of, lost track of a negative, the distance of the image, negative, we get a magnification of plus 0.250 as our magnification. So we see, as we would have expected, in a concave lens, we get a positive magnification that tells us that it is upright relative to the object, virtual, and it's smaller. Remember, our concave lenses always produced smaller virtual images. So it's consistent. All right, good job.